drop.
This video showed that in the car, when the car was dropped at 30 centimeters, it had an average of time at 0.23 seconds. This proved that the velocity average was 1.3 meters per second. This image encaptures the car's collision with the ground, which presents Newton's third law, which is for every action there is an equal and opposite reaction. In this scenario, it is the car's force of impact that presents itself as the action on the ground, and then the reaction is the force on the object coming from the ground. This image shows that the crumple zone on the car, made from plastic bags with punctured holes in it, has deflated at the collision point in order to decelerate and extend the crash's period, absorbing the force. As the car falls, it experiences the net force whilst being pulled down by gravity. When the car is held in preparation to be dropped, it is at maximum potential energy. When the car is dropped, it converts from potential energy to kinetic energy, because as kinetic energy, as in motion, increases, potential energy, the stored energy, decreases. This is proven by the law of conservation, which establishes that energy cannot be lost or gained, only transformed or converted. So we see that the car releases heat and sound as it hits the ground. Immediately before the car collides with the ground, it undergoes maximum kinetic energy. When it then reaches the ground, it converts into elastic potential energy. The slow motion depicts the car springing back up whilst it is in the elastic kinetic energy, before it is then pulled down due to gravitational pull. Another contributing factor, such as air resistance, pushes the car from sideways and underneath, lengthening the fall, moving in the opposite direction of gravity. The immediate second before the car hits the ground is called the force of impact. For this 30-second drop, the kinetic energy scaled to 0.092 joules, and the potential energy was 0.3234 joules. The first drop impacted the two apricots with minimal damaging, resulting in an average of 0.93% of injury. This is because the smaller height provided a lower gravitational potential energy due to the smaller height, and less gravitational pull. Because there was less velocity due to the shorter height, there was a smaller force of impact, which decreased the impact on the fruit, resulting in lower percentages of damage. The pink annotations above are consistent for all three heights trials and are described in the previous video. This trial was dropped from 100 centimeters and had an average time of 0.58 seconds, proving the velocity as 2.97 meters per second. The kinetic energy in this drop was 0.0946 joules, whilst the potential energy was 1.078 joules. Potential energy is greater than kinetic energy because the motion of the car in kinetic energy loses energy to friction, heat, and sound. Once again, the video displays the crumple zone deflation in accordance with the collision in order to decelerate and extend the time period. The images of the fruit display still minor damaging of bruising, but the damage average percent increased by 10%, increasing it to 103%.
1, go!
This trial had a time average of 0.7 seconds and a velocity of 3.63 meters per second. The kinetic energy calculated to 0.16196 joules and the potential energy of 2.64 joules. In the third height test of 250 centimeters, the force of impact is visibly greater and has a calculated force of 0.56 newtons, compared to 100 centimeters, which was 0.32 newtons. This image shows that the crumple zone has intensely deflated due to the impact. If you can see the slow motion again, we can see that the car bounced up again after hitting the floor. This is due to elastic potential and kinetic energy, and Newton's third law of equal action and reaction. The greater force, specifically the car, has acted on the ground, so the equal force is reacting on the car, making it bounce up again and then landing, which then lands cushioned by the egg carton. In this trial, the damage of the passengers was 8.85%, but that included various marks, bruising, or dents. The damage from this trial was more obvious and visible to the eye. In order to test how effective the safety features were in preventing the damage of the fruit, an empty tissue box without safety features was utilized. The trials of using the loose car showed what would happen to the fruit if there was no safety features. Trial 1 had an injury percentage of 2.35% compared to 0.93%. Trial 2 had a damage percentage of 7.6% compared to 1.03%. Trial 3 had a damage percent of 77.25% due to splatting compared to 8.85%. The substantial difference proved that the efficiency of the safety features